Well, this lesson is going to focus on the difference between average rate of change and average value, which can be very confusing depending on what you are given. So let's look at a couple of examples. So first of all, we are given the position of a particle on the x-axis, which is modeled by this function. Now we're asked to find the average velocity. So if I'm given position, if I do the change in y values, so the change between x of e minus x of 1, so that would be the numerator, divided by the change in the x values, which would be e minus 1, you can see really I am finding the slope. So I'm finding the slope of the position. And so we know then it would be the natural log of e minus the natural log of 1 all over e minus 1. And I know we're solid on our logarithms, so the natural log of e is 1, natural log of 1 is 0, so it's 1 over e minus 1 would be the average velocity of the. Now you try the second one first, so answer the question and then see if you get it right. Okay, so for this problem, again, we were given the position of a function, and we are asked for the average velocity is equal to 0. So we know to find average velocity, we would do slope, basically, since we're given position. So it would be x of the second value minus x of the first value, all over the change in b minus a. So change in y over change in x is equal to 0. Well, since the fraction is equal to 0, we know that we can just basically set the numerator equal to 0. So we'd have x minus b minus x of a equals 0. And since we are beginning at time equals 0, we would have x of b minus x of 0 equal to 0. Okay? And so now, since I'm kind of running out of room here, I'm going to go up here to the top. So x of 0, of course, is 0. So we end up with, when we look at the function, we have 3t cubed minus 18t squared plus 24t is equal to 0. Sorry, my lines. There we go. And so here now this would just be a simple problem where we need to factor it. So we see the GCF of 3t, and we have t squared minus 6t plus 8 is equal to 0. And we'll factor again. So now we have t minus 4 times a quantity t minus 2. So we see that we have three values where the average velocity would equal 0. T equals 0, t equals 4, and t equals 2. Let's have you try one more now. Okay, so you first try to solve this problem, and then you'll see if the answer is correct. Okay, for this problem, again, we are given m of t, which represents the grams of a tumor after t weeks in. Now, if we want to find the average rate of change, we're actually going to have to do slope once again. And since it's during the 5th week of growth, we would go m of 5 minus m of 0 all over the change, which would be 5 minus 0. So we'd have 5 e to the 5th all over 80, and then basically multiplied by 1 over 5. And simplifying that, we see we get e to the 5th over 80, and it would be approximately 1.855. Now, since you are given this problem with units, since it's the rate of change, then it would be average grams per week. Now, what do you notice about these three problems? All three of these problems, what information were you given? Notice you were given basically the original function where it was grams, it was position, and you're asked to find the average rate of change. So that's when we incorporated our slope formula. Okay, so this is just a summary of what we were looking at. So if you're asked to find the average rate of change, it would always be f of b minus f of a all over b minus a, right? Change in y over the change in x. If you're given position function to find the average velocity, again, the change in y over the change in x. If you're given velocity function to find average, change in the velocity over the change in time. All of these really are dependent upon what you are given. Now in this example, we're actually going to look at a sample FRQ, where we have a cylindrical can with a radius of 10. It's initially empty, and so we know that the units that we're given here are millimeters, and it's measured in days. And the function we're given is the rate. So we're given millimeters per day. Now if you're asked to find the average rate of change in the height, we basically know to find average rate of change, we would do the change in height over the change in days, or the change in x values. So basically we would go s of 60 minus s of 0 all over 60 minus 0. But we're not given s, we're given the integral. Well, we know according to the fundamental theorem that the s of 60 minus s of 0 is the same as taking the integral of s prime t dt, all divided by 60. So you can see this is how we incorporate the average value with average rate of change. And then I would continue and solve this problem to find the answer. So if we kind of complicate it a little bit to make sure you fully understand, we're given a function that is a value of an integral. Now we know by the fundamental theorem that the derivative of f would be the integral evaluated at x. So it would be cosine of x squared plus x plus 1. Now this will serve us to be useful in the next couple questions. So you're asked to find the average rate of change of f. Well, we know to find average rate of change will be capital F of 7 minus capital F of 3 all over 7 minus 3. Okay, well, we are given f of x, it is the integral, so basically we would be having to find the capital F of 7 minus capital F of 3. We know that to be the integral then from 3 to 7 of the integrand, sorry my cursor isn't working that fantastic, cosine of x squared plus x plus 1 all over 7 minus 3, which is 4. Because by the fundamental theorem, we know this to be true. Now what if you're asked to find the average rate of change of f prime? Well, again, it's the same formula. It's f prime of 7 minus f prime at 3 all over 7 minus 3. So you have to look at what you're given. So since we know the derivative of an integral is the integrand, basically then what we would need to do is we would need to evaluate then cosine at 7 squared plus 7 plus 1 minus cosine at 3 squared plus 3 plus 1 all over 4. So it's very important to understand what you have. Okay, looking at that same problem that we had earlier, the FRQ, what I'd like you to do is now interpret these two expressions. Using correct units, explain the meaning of the first integral, and then explain the meaning of the second integral. Okay, let's see if you got the right. The meaning of the first one, notice we're taking the integral of s of t. And s of t is not the rate, s of t would be the millimeters. So by doing this, what we're finding is we are finding the average height. Now what's the unit? You always have to say the unit. So it's the average height in millimeters of the water between 0 and 60 days. Now don't scrimp on writing this, explaining the meaning of this, because if you don't include all of the units, you will lose easy points. Okay, now if that's the average height, then when I take the integral of the s prime t, what will that be? Well, we know the integral of s prime is s of 60 minus s of 0. So this will give us the average rate, that the water is rising in 60 days. That the water is rising. So it would be what, millimeters per day? So the average water is rising in millimeters over 60 days. Okay? So make sure you fine-tune those explanations. Okay, now this is a different FRQ. So see if you can find the average rate between 0 and 8 first, and then check your answer. Okay, for this example then, average rate, again, it's the average rate at which the water is draining. So we would need to find capital R of 8 minus capital R of 0 all over 8 minus 0. Now I'm using capital R because that would be the antiderivative. But I'm not given the antiderivative, I'm given the rate. So then I would have to go the integral of the rate. Now since it's a piecewise, I would have to divide it up from 0 to 5 and then add up the change in value from 5 to 8 of, oops, I should not have written R of t because R of t is the whole piecewise. I should have written 600t over t plus 3. So that's the first piece. And then we'd add it from 5 to 8 of 1,000 e to the negative 0.2t dt. and that would be all over 8. And that would give us the average rate at which the water is draining. Okay, now we're looking at a numerical perspective. So in this example, we are asked for the approximate the rate at t equals 6. Well, notice in this example, we are not given a rate of change. We're given the number of entries and we're given time. So to find the rate, we would have to subtract e of something minus e of something all over the change in time. Well, since 6 falls between 5 and 7, we are going to go e of 7 minus e of 5 all over 21 minus 13. So then your answer should have been 4. Now make sure you clarify with units what this is. So this is 400 entries per what? Per hour. Okay? Always include units if you are given units. Now the further parts of this FRQ. So now we are asked to approximate the value of this expression, and you have to explain the meaning. Well, we know how to do a trapezoid. I'm not going to focus on that, but I'm going to focus on the meaning here. So we're taking the integral of e of t all over 8. So the meaning of this would then be the change in the hundreds of entries between, so notice I used units of entries between 0 of entries between 0 to 8 hours. Okay, great. Now how is that different then from 1 over 8 from 0 to 8 of e prime t? Okay, so think about that. What would that answer be? Okay, so for this answer then, this would be the average rate. Okay, the average rate. Ooh, I notice when I write in cursive that you don't hear the clicking, huh? That entries in hundreds, remember, don't forget your units. But my cursive is much sloppier. Between 0 and 8 hours. You have to make sure you include all the units, okay? Great. Okay, I think this is our last FRQ. So notice on this time, what are you given? You always look at what you're given. So you're given the temperature and you're given the change in distance. We are not given a rate of change. So what would be t prime 7? So go ahead and solve that. Okay, so again, you're finding the rate of change. So it would be t of 8 minus t of 6 all over 8 minus 6. And your answer for that should be negative 7/2. Now what are the units? It's degrees per centimeter. Okay, so now you're asked to write an integral expression for the average temperature of the wire. So go ahead and write that integral expression. Okay, so the integral expression should have gotten was from 0 to 8 t of x dx all over 8. That would be the average temperature of the water. And using your trapezoidal approximation, then you would get 75.688 degrees Celsius. Now, notice how they just keep coming back, repeating this. How is this integral different from the one we just did? Well, we know that by the fundamental theorem, this is basically saying t of 8 minus t of 0 all over 8. And we can see that we are finding the average rate of change. So this would be the change in temperature from 0 to 8 centimeters. And then the answer, I believe, that you should get is 45. It's a negative 45 degrees Celsius. So the change in temperature from 0 centimeters to 8 centimeters drops 45 degrees Celsius. And then here are the full answers to that rubric. Now I hope this helped clarify average rate of change and average value.